You are listening to Specifically for Seniors, a podcast designed for a vibrant and diverse senior community. I'm your host, Dr. Larry Barsh. Join me and a lineup of experts as we discuss a wide variety of topics that will empower, inform, entertain, and inspire as we celebrate the richness and wisdom of this incredible stage of life. A recent space tourism flight on the Blue Origin capsule featuring an all-female crew, including Katy, Gayle King, sparked some controversy over whether it was a publicity stunt to promote Jeff Bezos' space tourism business or whether it had some scientific purpose. We were curious about humans' commercial venture into space, so we called on the go-to expert on all things spaceflight, Dr. Jonathan McDowell. Dr. McDowell is an astronomer and astrophysicist at the Harvard-Smithsonian Center for Astrophysics Chandra X-ray Center. He studies black holes and quasars and leads the science software algorithms team for the Chandra X-ray Observatory. McDowell's astrophysics publications include studies of cosmology, black holes, galaxies, quasars, and asteroids. Jonathan is also the editor of Jonathan's Space Report, a free internet newsletter founded in 1989 covering technical details of space launches. He is the archivist of world space flight knowledge. Welcome to Specifically for Seniors, Jonathan.
Thank you very much.
Absolute pleasure to have you on. What's your opinion of these space tourism flights? Necessary or a distraction?
I think they're great. I mean, yeah, there's absolutely no scientific value to them, and there doesn't need to be. Not everything. As a scientist, I love science, but not everything in the world has to be about science, right? And so, should we have, I don't know, scientific ship voyages to Antarctica to study the oceans? Yes. Should we also have cruise ships with people just out there for fun? Why the heck not, right? And so I think that a lot of the foofra about this flight is people not really getting used to the idea that space is just another place that humans do stuff now, and we do science, we do business, we do and we do tourism. And I really don't see anything wrong with that. Now, what you might object to, right, is that there are so many people rich enough to spend their money on this, right? And that, that our tax system is such that there's a whole bunch of people with money to spend on frivolity like this. No, frivolity isn't bad, but excessive frivolity that costs millions of dollars, perhaps we should be taxing these people a bit more. But given that that's our tax system right now, I don't have a problem with people using it on that. And I want to say there are some benefits to humanity from even these completely frivolous fun rides, right? Which is that it gives the rocket engineers experience in launching these things regularly, in making them safe enough that you can fly Katy Perry on it and not worry that you're going to be embarrassed by blowing her up. And so that does get us to a future where it's cheaper for the rest of us to do this kind of thing. I think that's always true. So that's my take on it.
I had never thought of it that way. That's an interesting perspective.
Yeah, you've got to. I mean, I think we have to get over the, space is this special thing. One thing I really want to get across is I think the final frontier, has moved out, right? The final frontier used to be the boundary of the atmosphere, getting into orbit, getting into outer space. Yeah, that was ages ago. The frontier now is the moon, and pretty soon, even we're now starting to see commercial companies go to the moon, developing countries go to the moon, and even Mars. The frontier is going to move out to the asteroid belt and the outer solar system, and even the moon and Mars, which are going to be just like, yeah, that's just local ordinary stuff now, and we're going to see all kinds of regular activities there that are nothing to do with science and exploration.
We've all heard of the Hubble telescope, but I don't think many of us know about the Chandra X-ray Observatory. What's its mission? What is it?
Yeah, so Chandra is Hubble's X-ray cousin. And so X-rays are just a very, very blue ultraviolet kind of light, right, that our eyes can't see. And it's produced typically when things get very hot. And so out in the universe, there are a bunch of things where we have very energetic events, matter being torn apart as it falls into black holes, stars that explode in a supernova. And in those events, gas gets heated to millions of degrees, seriously hot. And so when that happens, if you have a cloud of gas that's at 1,000,000 degrees and you look at it, it'll be completely transparent. You won't see anything. But if you look at it with X-ray eyes, it's shining really bright. All of the energy is coming out in X-rays. And so when the Hubble telescope looks at these objects, they don't see anything. They just see the background stars. They look right through it. Completely miss all of the interesting action that's going on. And so you need Chandra to come in and tell you what's happening in the hot universe in the area that you're studying, to complement what Hubble tells you about the cool and warm universe that it studies.
How did you get interested in space?
Well, my father was a scientist. I thought what he did was really boring, but all of my babysitters were physics graduate students, and so I was sort of infected from an early age. And I got into, I guess, sci-fi shows on TV, like Doctor Who started when I was 3 in the early 60s. And then, I got interested, I was 9 years old when the Apollo astronauts landed on the moon. And I can remember walking home from school the week before the launch, seeing the moon in the sky, and thinking, wow, for the first time in history, next week, there are going to be human beings on another world up there in the sky. And that just blew my mind. And so that was one part of it. Getting into space was being inspired by Apollo. And then I also was sort of interested in bigger philosophical questions. Where does the universe come from? What is this universe anyway? And I didn't find, religion a satisfying answer. And so I got interested in cosmology and astrophysics for that reason. And so those two routes kind of eventually came together to forge my career.
You mentioned Doctor Who. Very serious question.
Sure.
Do you agree with... I'm
Who's
sorry.
my favorite doctor? Is that the question or not?
Well, do you agree with me that the only real Doctor Who was Tom Baker?
No, I'm sorry.
Oh.
Patrick Troughton, the second Doctor in the early '60s, has a special place in my heart, as does David Tennant from the more recent series. So I'm on team. There are lots of good Doctors. See, I think Americans tend to fixate on Tom Baker because that was when it really came over to the US. But having grown up in England, I sort of saw the OG, the original Doctors.
And then his follow-up on Little Britain just sort of clarified it for me.
Right.
You got your PhD from Cambridge and got to hang around with Stephen Hawking.
And many other really top end scientists. Yeah. So my advisor was a guy called Bernard Carr. So in a PhD, it's very much an apprenticeship, right, where you have a thesis advisor and it's a very personal kind of intense training. Um, and Bernard was an expert on mini black holes and black holes generally, and and Stephen had been his PhD advisor. And so he would drag me along when he would have lunch with Stephen or something like that. And so I would just sit in the table, be at the end of the table, being very quiet and kind of, trying not to make too much of a fool of myself. But it was really inspiring. I learned a lot from that group. Also, Martin Rees, who's the Astronomer Royal, just fantastically smart people. And really interesting ways. I've tried to sort of take the ways they asked questions about the world and learn from that how to ask the right questions, which I think is really one of the key things.
I mentioned that you were the go-to guy for all things spaceflight. You've been writing and maintaining Jonathan's space report since 1989, cataloging every space flight.
Yep, that's right. And I really started this in the '70s as a teenager. I found a list of rockets in the back of a book and copied it down, because I was so interested in the space stuff. And I realized that actually their list wasn't very good, and so I taught myself to do the research to make a better list. And 50 years later, my list is generally acknowledged as the best in the world, and so I think it's a testament to, if you are willing to nerd out enough and ask a narrow enough question. In my case, what is the list of all those satellites that have gone up? It's actually, it's not that hard to become the world expert. I mean, it takes 50 years of hard work, but you just have to be sufficiently obsessive. So I've had fun with that project because it's been an excuse for me to dabble in all kinds of questions that are ancillary to the question of which satellite went up. For example, I've visited space rocket launch centers around the world to go, ooh, can I look in your basement for your lists of rocket launches? And so I've been to the Centre Spatial Toulouse in France. I've been to the Vikram Sarabhai Center in India. And so I get to, to explore and discover all kinds of interesting things, learn other languages so that I can translate the press releases from the different countries and so on. And so it's been a great excuse to learn all kinds of things that you wouldn't immediately think were related to rockets and space.
So, how much stuff is up there?
So there are now 11,000 working satellites and about the same amount of trackable space debris, junk, leftover rocket stages, pieces of exploded satellite, things like that. And the US Space Force tracks it with their radars and telescopes every day. And so we keep getting updates of where everything is, whizzing around in low orbit at 17,000 miles an hour. And so it's getting more and more crowded up there. And so I've gotten dragged in just, initially my interest is being this, let's make a list. But now, as the list got bigger, I went, there's an environmental problem here. And so I've been drawing attention to some of the challenges that managing this free-for-all in space that we have right now, with many different countries, many different commercial companies whizzing around at incredible speeds.
When's all that going to become a problem?
Well, it's already a bit of a problem. It's going to become a big problem, I think, within the next 10 years. And in fact, as usually in the environmental stuff, you have to do the research to find out how big a problem it is. For example, there are so many satellites going up now that there's also a lot of older satellites coming down, and we're burning them up in the upper atmosphere. The bigger satellites can survive So we've got a satellite coming down this weekend that is going to survive re-entry. It's about half a ton. Probably it will fall in the ocean. Most of the Earth is empty, but there's some small chance that it'll hit someone on the head. So that would be really bad. And then the smaller satellites burn up entirely, but that's doing something to the chemistry of the upper atmosphere. Excuse me. And we don't really know. We think probably it's not terribly bad, but the uncertainty is enough. We need to run the science models to understand, are we actually screwing up the upper atmosphere with all of these incinerated satellites? And so so there's a whole bunch of questions that come as we go from we're just doing this a little bit to we're doing this a lot, and what effect is that having?
So it potentially could have an effect on climate change.
Absolutely. It could have an effect on the ozone layer, for example. And so, I don't want to overstate it. We don't know that that's a problem yet, but it's enough of a possibility that it really needs to be looked at more carefully before we up the level of doing this by another factor of 10.
So are we leading to the same kind of environmental problems as we've caused on Earth?
Absolutely. I remember when people said, oh, the oceans are huge and we can put all the junk you like in the oceans and it'll never be a problem. And now we've got, the big Pacific plastic patch and everything. And I think the same attitude in space, right? Space is huge. Well, it is. But low Earth orbit isn't infinitely huge. That's the area that we mostly send our rockets and satellites to. And we're actually starting to, not fill it up in terms of the satellites actually being close to each other, but because they're going so fast, they're whizzing past each other all the time, and so we're starting to reach capacity, I think, in outer space, in the near part of outer space, and that's something that 20, 30 years ago people would have laughed at, but yeah, it's happening.
So is there any potential to clean that stuff up?
Absolutely. And there are a number of interesting companies that are developing the technology to do it. So there's a company that's sort of Japanese British called Astroscale that's been going up and practicing going out to pieces of space junk and figuring out how to drag them to a safer orbit or for disposal. And so I think, we will start seeing that in the next 10 years. We'll see the space garbage trucks come on the scene.
Are you going to be around to supervise this?
Well, perhaps. So I am retiring from my job as an astronomer in the next few months. But, if you know any academics, you know that you have to put retired in air quotes, right? When we retire, it just means we're on committees and I'll be doing consulting work. And I'm going to refocus away from the astrophysics onto what we call space sustainability, making sure that the scientific and commercial use of space can carry on successfully in the years to come and not be not run into a roadblock because we're trashing the environment. And so, as part of that, I'm going to be moving to the UK. Which is one of the world leaders in that area, and collaborating with people in the UK.
We don't hear a lot about that part of space. We hear a lot about the exciting launches and being able to get a rocket back on its launching platform. We don't hear about the cleaning up the mess we're making up there.
That's right. It's not. It doesn't get the publicity. It doesn't get the clicks that famous people, celebrities, having their little ride in space do. But I think also people don't understand how much of their daily lives are actually entangled with space even today. And I mean, the obvious thing, right, is GPS. People of our generation still probably can read a map. The younger generation have no idea how to do that. They just get GPS to tell them where to drive, and so every day people are using space technology just to get around, and but also your smart devices are flowing data over satellites to their hubs to help them work. Um, when you check where your friend's airliner is on the way to meet them, how far are they across the ocean and so on these websites, they're using data flowing over satellites to give you when your FedEx package is going to arrive, right, and see that be tracked. That's also data that flows over satellites, and so as well as a lot of what we know about climate change is from NASA research satellites. And so space affects almost every aspect of our lives today, but it does it in this invisible way that means the average person doesn't really know it's happening.
I guess the other question I have is, how is artificial intelligence beginning to affect space research?
Well, it has its uses. I think there's a lot of hype about AI that is let's say overblown. But when you have a problem that's like look through a lot of data for a pattern, AI is very good at doing that. Where we used to use a room full of graduate students, and so it's used a lot. For example, in going through big databases of space imagery of the Earth to identify where are the places where there's erosion, where are the places where the crops aren't healthy, things like that. Pick out the interesting or worrying areas, and so I think that it has a real use there. More generally, I think it remains to be seen.
Is it really intelligence, or is it machine learning?
Yeah, it's mostly machine learning, and what is intelligence? We really don't understand that well enough to say. Perhaps my sense is that the smartest computers right now have the intelligence maybe of a small insect, that we're a long, long way from having. I do believe that machine intelligence is possible. I just don't think we're close to it yet. The things that are happening with these large language machines, large language models, are not intelligence in the way that you and I understand it. They're very clever searching and pattern recognition, but they're not intelligence. But that doesn't mean that intelligence won't come at some point. It's just going to be a while.
First, we've got to get it going on Earth.
Well, that's right. Yes, is there intelligence among humans? That's still an open question. Yeah.
On a side question that's always bothered me, that has nothing to do with space debris. It's been estimated that the Big Bang occurred 13.8 billion years ago. How do you measure time when time didn't exist?
Right. Well, time did exist then. Time didn't exist beyond the Big Bang. And so you have to use different coordinates there, and that's a whole other story. But when we had the Big Bang, one of the things that we have this infinite, very hot, very dense universe with the laws of physics in place, and with space and time coming into existence, and my way of thinking about it is at the very moment of the Big Bang, space and time kind of melted, if you run the movie backwards, to some blurry quantum thing that wasn't either space or time. And then as the Big Bang progressed, they froze out, and you have space and time as we know them. And so since then, space and time have had their normal meanings. And when I say normal, I mean as Einstein taught us physicists, so it's not perhaps as normal as the average person thinks it is. And so we can measure. And so let me tell you a story, right? Which really brings how I feel the wonder of astronomy. When you have an atom, let's say a sodium atom, and you shake it, the electrons in the sodium atom jump from one quantum state to another and emit a photon, a packet of light. And the color of the light depends very precisely on the amount of energy change in the electron going around the atom. Bear with me here because this gets simpler. So what that says is if you shake a sodium atom, you get actually an orange colored beam of light that's a very, very precise shade of orange. And if you see that shade of orange in your data, you know, that's the fingerprint of sodium. It's actually two different shades of orange a little way apart, right? And so it's a very characteristic fingerprint of that atom. And we see that fingerprint in the light from galaxies that are billions of light years away, and we're seeing them as they were billions of years ago. And so that's what that tells you is not only are galaxies made of the same stuff as you and I, but that the laws of physics were the same 5 billion years ago, 5 billion light years away, because if you take a sodium atom and shake it, it puts out exactly the same kind of light, right? And so that says that the rules of the game are the same throughout space and time, throughout the universe. And that lets us understand what's going on. And so then we can measure distances to distant things. And there are various clever ways that we do that we don't have time to get into. But we are now very confident that the time from, so there's the Big Bang and the universe is sort of like on fire and it expands and cools, and at a certain point it cools enough that the atoms become neutral instead of ionized, and that makes the world transparent. And so there's a moment when you go from Big Bang fireball to transparent universe with black skies. I say a moment; it takes a few thousand years, but it's and then the light rays that have been bouncing around inside the fireball, not getting very far, start going in straight lines forever until they hit our telescopes 13 billion years later. And so we can take a picture by looking very far out in the sky of the parts of the Big Bang that are the light from that moment of going transparent that is just reaching us today. And it's that picture that then we can measure the age of. And so from that, we can tell, that's where we get this 13.7 billion years, and then another 0.1 for the bit from the actual Big Bang to where it became transparent is based on sort of physical arguments.
And being able to measure the components, the chemistry of the light can give you an idea of whether life develops in distant location.
That's the hope, yeah. And so this amazing thing that when you look at the light from something, and this is called spectroscopy. If you go to the lab and you heat up a substance and you look at the light it emits, you can tell what elements it's made of. There are these characteristic signatures. And so you can do that in the light from distant stars and planets, and you can tell what they're made of. And so the hope is that our telescopes are on the verge of getting good enough that we can do this trick, this kind of CSI on the light from planets going around other stars to see if there's oxygen in the atmosphere, to see if there's carbon dioxide in the atmosphere, to see if they would be see how hot the atmosphere is, to see if there's water there. All of these questions are in principle accessible to, if not today's technology, at least tomorrow's technology. And so we're on the verge of being able to do that. So the hunt for life in the universe is seriously on now, after millennia of people pontificating about it and speculating. Now we have the ability to really ask technical questions and do a real search for it.
So the obvious question is there life out there?
Yeah, I mean, what we know now that we didn't know 20 years ago is that almost every star in the sky has planets going around it. So planets are common in the universe. Planets the size of Earth are common in the universe. But a lot of them are pretty unpleasant. They either don't have an atmosphere, or they're too hot or too cold, or. But still, there's so many out there that there's got to be some that are nice. We haven't found any yet, but just from the statistics, you got to believe that there are places out there. I think we'll find that life, that very simple life, like bacteria level life, is actually pretty common in the universe. I think most astronomers would guess that at this point. We can't prove it yet, but that's kind of the direction that the clues are pointing us. And then the question, but you don't want bacteria, right? You want Klingons, right? You want
No, you don't want
or,
Klingon.
or maybe Vulcans, right? You want people you can talk to, right? And that's a lot harder. And I think it's a big universe out there. Surely we're not entirely alone. There's no evidence of that yet. It's clear. What is clear is that intelligent life, civilized, a technological life, isn't very common, because we'd have spotted it by now. We don't see obvious signs of alien activity, despite what you may read in the National Enquirer. There's no all this UAP nonsense. No. If the aliens come, right, it's going to be more like the Independence Day movie, when you have like 10-mile diameter spaceships hovering over New York and so on. You're not going to miss it. And that's partly because so one of the things people always get wrong about aliens is timescales. Timescales are very important to astronomers, and the relevant timescale here is our species is like 1,000,000 years old. I mean, if you want to be specific about Homo sapien, modern Homo sapiens, only a few tens of thousands of years old. The age of the galaxy is 10 billion years, right? And so the time scale on which species evolve, right, is much shorter than the time scale of the galaxy. And what that means is, if you meet aliens, they're not going to be the same age as you. Like, suppose I walk out of this on the street now and ask the first person I meet, "How old are you?" Probably they're going to be a bit older than me or a bit younger than me. They're not going to have maybe I was born July 6, 1960. All right. Now, maybe they were, I get lucky and I find someone who was born in 1960, but I'd be pretty surprised to meet someone who was born July 6, 1960. That would be really unlikely. And if you translate that to the timescales of galactic evolution, the first aliens you meet are not going to be the same age as our species. They're going to be hundreds of millions of years behind us, so they're still ants, or they're going to be hundreds of millions of years ahead of us. They're kind of going to be like gods to us, right? They're not going to be Vulcans and Klingons and whatever other alien you're familiar with. And so that is the thing that we have to get in our minds, is that the timescales are so long. We may have missed, if species don't last that long, right? If we all blow ourselves up after 1,000,000 years or so, then the chance that there's another species in our galaxy right now isn't that big, because they probably all died out or haven't evolved yet.
Any closing comments, any thoughts on the importance of continuing research, both from the perspective of human space exploration and from the perspective of basic knowledge of the universe?
I mean, so I'm coming to the end of my career. When I look back on what humanity has learnt in that time, uh, I have been uh, amazed at the progress that we've made. Not just in little things like how far away is that star and so on, but in deep philosophical questions about how that people have had for millennia, right? Are there the multiplicity of worlds? Are there other worlds like the Earth? Right? Oh yeah, there's billions of them through the galaxy. Question solved. you know, are there? How old is the universe? Right? Is it 4,000 years old? Is it millions of years old? Is it billions of years old? Oh, it's 13.7 plus or minus zero point 0.1 billion years old. Solved. Next question. And so these really, that's the great thing about astronomy, is you can solve these really fundamental questions. And then the other thing I would say is that the in the terms of the space exploration, right? As we move out into space, we are not just going as humans. To survive, we have to take our biosphere with us. And so we have to we have to take bacteria, but also other creatures and so on. We have to take plants to eat and things like that, right? When we actually settle other worlds, it's going to be the whole terrestrial biosphere that goes with us. And so this is actually a moment as significant as when life first went from the oceans to the land, right? Is that it's not just humans going to space, it's the terrestrial biosphere, the whole panoply of species finding a new ecological niche in space and not just on Earth. And so that to me makes this, our lifetimes that we're living through, such a it's a 1 in a billion year historical event, right, that we're living through. So appreciate it.
Jonathan, this has been fascinating. Thank you so much for coming on.
My pleasure.
It's been a joy. Thanks.
If you found this podcast interesting, fun, or helpful, tell your friends and family, and click on the follow or subscribe button. We'll let you know when new episodes are available. You've been listening to Specifically for Seniors. We'll talk more next time. Stay connected.